Okay, so today, what that activity and Desmos is supposed to do is help you start thinking about what these graphs look like. All right, so I'm going to zoom in on this part. By the way, if you want to grab the notes for today, I'm now in the notes that are posted for today. You don't have to be on those, but at a minimum, you're either in the Desmos activity and finishing that up or looking at these notes. Okay, next up. This guy, most important term. It's called the lead term. It's the boss. It's got the highest rank. It's got degree 2. See that little 2 there? It's called the degree. And then this 8, that's called the lead coefficient. This one's also a coefficient. It's just not the lead coefficient. Okay. Did you notice something about those coefficients? I'll give you a little hint. It has to do with if they're negative. If this lead coefficient is negative, something special happens with the graph. Let's move on. What is standard form? I think the easiest way to say what standard form is by showing you what standard form isn't. This one's not in standard form. What's weird about the one I just wrote? Yeah. It's backwards. You got used to it, right? The numbers that are the biggest degrees, they go first. It's like the generals. 5x to the 5th, that's the biggest term because of the 5, not because of this 5. I shouldn't use the 5, but. And then the x to the 3rd is next, and then the 6 is last. That's like a private. He doesn't have any rank. He doesn't outrank anybody. He can't boss anybody around. Okay, so anyway, this one's the lead term. That's lead coefficient. Okay, is this one in standard form? Nope. The general is not standing at the front of the line. This right here, that should be moved to the front. Remember the negative that's stuck to this 5 here, that will stay on that 5. So if I move things around, just make sure you don't move the negative. The negative stays on the 5. Okay, look at this one closely. Is that in correct order, or is something weird? Mr. Lewinsky, what's weird about this one? That is a good question. This is definitely where the problem is. But by just putting it in front, I think there's a better way. Instead of switching them around. Bennett, do you know what to do?
Should you put the 4 first?
That's what he was saying. And I know a 4 is bigger than a 3, but that's not the question. Yes?
Should you simplify it and add them together?
That's what he just realized. Yes, you can put them together. So it's 6x to the 8th. And these two together make negative 7x squared. Why? Because negative 4 and negative 3 are on the same team. So they're both x squareds. So I can put them together. Minus 5x plus 8. So that was kind of tricky. It stumped 2 different people. These two needed to be put together to be in standard form. Okay? So it's about what rank they are. And if there's things that are like alike, these are called like terms. And like terms can be added together. Okay, moving on. Why do we put things in standard form? Once it's simplified, we can find how many terms there are. We could have found that either way. Didn't matter. Although we combined any repeats, you know, like the one where they both had x squared on them, or x to the 3rd on them. I don't really agree that we can more easily find the leading term, the degree, but the leading term does have the degree on it, so it's pretty handy if that's in front. All right, so looking at this polynomial, what is the leading term of the polynomial? Don't overthink this. What do you think the leading term is on this guy? Remember, the term is the bigger piece. Do you know which one's the leading term?
Oh, is it 4?
It is the 4x. And since it's the leading coefficient is the 4 because it's the number in the front. And the degree of that, there is no degree. Miss K, what do you do if there's no number on for the power? What do we put for degree? It is a degree 1. Because wouldn't it be like there's a little 1 right there? Does that make sense? Wouldn't it be like there's a little 1 right there? And so it's degree 1. Okay. And then, Dylan, what's the lead term on the next one? Yep. And Javon, what is the degree of this guy?
2.
Correct. And then the leading coefficient. Let's go with Quinn. Leading coefficient. -3. Now this negative, that tells me something about the graph being down, but it's not quite that simple. Did anybody notice from that activity? This meant that what part of the graph was down? Did you notice that? The last part of the graph is down. That's what that means. Last part of graph is down. You know, negative kind of means down, doesn't it? Like if I'm kind of negative today, I'm feeling kind of down. So down and negative kind of go together, right? And if your graph is going down in the end, then that leading term and the leading coefficient on that term is negative. Okay, so if there's a negative in front, this is the only one of these where the graph on the right side would be going down. All the other ones will be going up. And if you think about that, it's because you put bigger and bigger numbers in there. If you put in a number like, 2, it's not really easy to tell. But what if we put in 1,000 for x? Do you get if there's a negative in the front? It's going to cause this thing to be a big negative number. If you put in a really big number for x. Whereas here, if you put in a really big number for x, it's going to be a big positive answer. Y will be a big positive answer. Compared to this one, when you stick in a number for x that's big, you get a big negative number. That's why it's going down on the right. So if there's a negative in the front, it's going down on the right. If there's no negative in the front, it's going up on the right. I try to classify these things sometimes as if you want an A in this class versus if you want a B in this class versus if you want a C in this class. Okay, if you can just tell which things are which, like that's the lead term, that's the lead coefficient, that's the kind of thing you need to be able to get a C. Okay, the easy stuff. But the more complicated stuff, like that negative in the front, meaning the right side of the graph is down, that's one of the things you'll need to know to get an A in this class. Like the test. We had divided the test up into the easy part, which we hope everybody gets 3 out of 4 on, so then it can give you at least a C. Most of you guys aren't shooting for a C. You'd like at least a B or even an A. Well, then you need to know some of these things. All right. Last one, I'll do this one. The leading term is 2x to the 4th. The degree is 4, and the leading coefficient is 2, in case you'd already filled that one out. All right, moving on. So, what's the leading term? Well, duh, it's the one in the front. Is it always? Nope. Because sometimes it's not in standard form. Would you look at the middle one and tell me what should be in front? Joey? To the 5. Yep, negative 2x to the 5th. Should be in front. So the first thing you got to do is put them in order. Then you judge which one's in front. This one's really the leading term. A lot of people think it's just whatever's in front. And that's true if you've written it right. This isn't written right. So first you got to write it correctly in standard form. Then the lead term is in the front. And the lead coefficient is this. And if it's negative, it's going down on the right because negative people are down. Right? Huh? You know what I did there? All right. Okay. How about the lead term on the next one? Can you tell me on that third one there? Is this written in the right order? No. Nope. What should be in front? Trick question. Morning. Nice. What does that make? Yes. Now the lead term's in front. And now, by accident, I might have called that a trinomial earlier. It's not. Bertha, what actually is it? It's a binomial. Very good. Degree, Dylan. What's the degree of the one on the board? Degree 3. And what's the lead coefficient of the one on the board? 12. Very good. Since that lead coefficient is positive, it's going up on the right. Things are looking up because it's positive. If this had been a negative, then it'd be down on the right because negative people are down. Right? Trying to connect it. Only the right side of the graph. So when you look at these graphs, I right away, because I'm experienced at this, I look at this, and this, and this, and that. You know why? Because the right side's up here, so this one's positive. The lead term's got to be positive. This one's down, lead term's got to be neg. This one's up, so it's got to be positive. This one's down, so it's got to be negative in the front. The lead term's negative. That make sense to you guys? All right. Now, if you had grouped them this way, see, different people group them different ways. And I don't want to go through and like judge all of you based on how you grouped them, because you can, maybe you grouped them because they thought they looked like a letter in the alphabet versus not. You could have grouped them that way. But do you get if you group these all together? Both sides were up. If you grouped all of these together, both sides were down. If you grouped all of these together, one was up and one was down. And if you group these together, the left sides were all up and the right sides were all down. Remember what we were talking about before? The things that are negative are down because they're like depressed, right? Right. See? All we look at is the right side. The right side's the more important part. Okay, so when you're looking at a graph, focus on the right side of the graph because that's how the story ends. So, here's a typical test question. Describe the end behavior for the following polynomial. All right. So I have to teach you one last thing, and that's it. We're done for the day. It goes like this. This is a polynomial. It's got 4 terms. Once we go past trinomial, we just stop calling them names. We just call it a polynomial. Its lead term is negative 2x to the 5th. It's negative in the front, which is a big deal, because that means on the right, it's down. But how the heck do you tell what the left does? That's what I'm going to teach you next. All you have to know to tell what the right side does is if it starts being negative. If it's negative in the front, it's down on the right. If it's not negative in the front, it's going to be up on the right. It's easy. Right side's easy. Down if it's negative. Makes sense. Left side, here's how you decide the left side. The left side is based on the leading term, has a degree. If that number right there, that little tiny number right there, that 5, if that is odd, then it'll be different. So this was down, this one's up. See, they're different than each other. Doesn't different mean odd? I mean, kind of, really. If you saw a dog walking down the street on his front paws only, you might say, oh, that's odd. And your friend might have at the same time said, oh, that's different. You know how they kind of go together, odd and different? Okay, so if the degree is odd, it'll be different. What if the degree's even? Then it'll be the same. If I said you were even-tempered, that meant that you always stay about the same. If you're yelling at people all the time and then one minute you're happy, 1 minute you're sad, then you're not even-tempered, you're different-tempered. Your temper's more odd. It kind of varies. You can't tell. I'm sure you've had teachers that are like that. Who knows? Everybody is a little bit. I hope I'm not one of those teachers that's violently different, either really happy or really sad. But, you've probably had them. where you never know whether you're going to get the nice Mr. Server or the like mean, cranky Mr. Server. Again, all of us are affected sometimes by just what happened to us yesterday, or. But anyway, my point is that if this is even, then both the right and the left will be the same. But which are they? Are they both down or are they both up? You can tell. Quinn, what do you think? Are they both down or are they both up for this one? How do you know they're both up? So because the leading coefficient was positive, it had to be up. And then the other side had to be up because this was an even power. Does that make sense? This is not super easy, but you know what? Nothing that's really valuable is. All right. That is a polynomial. It's not a trinomial. It's got too many terms. Its lead term is 3x to the 7th. Its lead coefficient is a 3. The fact that that 3 is positive tells me the right side is up. The left side, the fact that the degree is odd makes me say odd. That's like the dog dressed in spandex waving a flag. That's odd. Or it's different. So it's going to be down. How many of you would have got that without me? Raise your hand if you feel like you got this. Okay. All right, good. So we have a little Schoology quiz on this. I originally had a worksheet, but I think I've got the Schoology quiz cleaned up enough that I'm going to assign that. So hold on just a second here. And I think that brings us to the end of the video for today.